Good day to you. This is Mr. Mlenga, your teacher of geography. So we are looking at weather and climate as our topic, but today I want us to specifically achieve these objectives. So among the objectives that I want us to achieve is to describe the three main types of rainfall. By the end of the lesson, I also expect you to explain the measurement of rainfall. You also describe the hydrological cycle. So those are the main objectives that I want us to achieve, including describing humidity and its measurement. Now, rainfall is something that is quite evident, and this is something that you are able to see. Now, one can wonder what it means. How do you define rainfall? Or what is rain in simpler terms? Now, rain is the amount of water falling from the clouds. Rainfall is caused by the effect of solar radiation. Now, when you just see the term or the word solar, what should come into your mind is the sun. So rainfall is caused by the effect of solar radiation over land and water bodies. So solar radiation refers to the energy from the sun. So this energy gives rise to various types of weather and climate. Now, solar radiation over sources or bodies of water causes evaporation. Now, how is the process of evaporation? Now, solar energy causes water to be transformed into vapor. So when a water body, let's take for instance, a lake, receives solar energy from the sun, the water in that lake is heated up and it turns into vapor and rises into the atmosphere where it condenses to form clouds. Now, this vapor enters the atmosphere by evaporation from the sea and land surfaces and transpiration from plants. So even plants also lose water through the process of transpiration. And this water goes into the atmosphere in form of water vapor. Now, the combined total of evaporation and transpiration is known as evapotranspiration. So you must be able to know that. It is known as evapotranspiration. Now, the rate of evaporation depends on the temperature of evaporating surface. Now, condensation. After the process of evaporation, what follows now is condensation. Now, condensation will occur if the rising air contains water vapor. The warm air rises, it is cooled, and its capacity to hold water vapor is reduced. The water molecules will pass into a liquid state and subsequently return to land and sea as precipitation. Now, when we say precipitation, we mean rainfall, snow, heat, different forms of, precipitation. Condensation may take the form of minute droplets of clouds, rain, mist, dew, or fog. So all those are forms of precipitation. Water of oceans, atmosphere, and land moves in a great cycle, which involves evaporation from the sea and land, condensation to form clouds, and precipitation in form of rain or snow. This exchange is what we call the water cycle or hydrologic cycle. So this is how the hydrological cycle looks like. Now, when you look at the hydrological cycle, first of all, you have a water body here. Now, this water body, when it receives heat from the sun, or the rays from the sun hit it directly, the water in this water body tends to warm up. And when water is warmed up, it rises in form of water vapor. And that is the process of evaporation. So water will evaporate from this water body into the atmosphere, as you're able to see, in form of water vapor. Also, from the plants lose water through their leaves during the process of transpiration. So the combination of evaporation and transpiration forms evapotranspiration. So water will move from the water body through the process of evaporation and go into the atmosphere, and also from the plants through the process of transpiration and go into the atmosphere. When this water goes into the atmosphere in form of water vapor, it condenses or it solidifies to form what we call clouds. So it will condense or solidify to form clouds. Now, when these clouds are formed, they tend to have what we call humidity. That is the amount of water vapor they contain. So when the amount of water vapor contained in the by the clouds reaches the maximum point, it starts falling in form of precipitation. And when it falls in form of precipitation, it now reaches the ground and runs back into the water body. So this is what we call surface runoff, the surface runoff. So the water will go back into the water body as runoff, and the process will continue just like that. So this is basically the description of the hydrologic cycle. Now, let me take you a step further by looking at the types of rainfall. Now, this is very important. In most of the past papers that I've seen, there are questions on the types of rainfall. Now, when you look at the types of rainfall, we have three main types. That is convectional rainfall, orographic or relief rainfall, and we have what we call cyclonic or frontal rainfall. Frontal rainfall or cyclonic rainfall is also referred to as convergence rainfall. So we're going to look at these three main types of rainfall in detail. Now, convectional rainfall is the type of rainfall that is the most common in regions that are intensely heated, either during the day, as in the tropics, or in the summer, as in temperate interiors. Now, when we talk of convectional rainfall, we'll say when the Earth's surface is heated by conduction, moisture-laden vapor rises because heated air always expands and becomes lighter. Air rises in a convectional current after a prolonged period of intense heating. When ascending, the vapor condenses into cumulonimbus clouds with a great vertical extent. So I'm gonna, explain this in detail. Now, this is probably, this probably reaches its maximum in the afternoon when the convectional system is well developed. Hot rising air has great capacity for holding moisture, which is abundant in regions of high relative humidity. As the air rises, it cools, and when saturation point is reached, when we say saturation point, we mean the maximum, point water vapor can be held in the atmosphere. That's the point of saturation. When it is reached, downpour occurs, accompanied by thunder and lightning. Now, here is the simple description of convectional rainfall. Now, here we are able to see that the basic thing that you need for there to be convectional current is the sun. So the sun hits the ground. So the sun will hit the ground. So when it is heated up, you discover that the water body will have water rising in form of water vapor through the process of evaporation. Also, the trees and other vegetation will lose water in form of evapotranspiration. So this water goes straight into the atmosphere. As you're able to see here, moist air rises or water vapor rises into the atmosphere. When it rises, it cools. When it cools, it condenses to form clouds. And these clouds, they contain so much water vapor that when they reach a point of saturation, the water will start now falling in form of precipitation, which can be an example of rain, snow, fog, and so on. So this is a basic description of convectional rainfall. Now, let me take you straight into what we call orographic or relief rainfall. Now, unlike convectional rain, which is caused by convectional currents, orographic rain is formed whenever moist air is forced to ascend a mountain barrier. Now, for you not to ever forget what orographic rainfall or relief rainfall means, is you must know the meaning of the word orographic. Just the word O-R-O, oro, means mountain. So orographic, we are simply talking about a mountain. So this is the type of rainfall that you find in mountainous areas. So orographic rainfall is the type of rain which occurs when moist air is forced to rise up or to ascend a mountain barrier. Since it is covered by the relief of a land, that is why we call it relief rainfall. Now, it is best developed in the windward slopes of the mountains where the prevailing moisture-laden winds come from the sea. The air is compelled to rise and is thereby cooled by expansion in the higher altitudes and subsequent decrease in the atmospheric pressure. Further ascent cools the air until the air is completely saturated, where you have the relative humidity 100%. Condensation takes place, forming clouds and eventually rain. The other side of the mountain, where there is little or no rainfall, is called the leeward side, or shadow rain. So the wind is dry and does not bring rainfall. The area is termed the rain shadow. The best example of such an area where you have the rain shadow on one side is the Luangwa Valley in the lee of the Muchinga, escarpment. Now, here is how orographic rainfall look like. So what is key for you to have for there to be orographic rainfall or relief rainfall is a mountain barrier. So you need to have a mountain barrier. So what happens is that you have moist air coming from the sea on one side. So this moist air coming from the sea will move towards the mountain barrier, and as it meets the mountain barrier, the air which is moist is forced to go up. So it will go up, and when it goes up, it will cool down and it will condense to form clouds which bring about rainfall on the windward side. So this is what we call the windward side. Now, we also have this other side, which is the rain shadow region or the leeward side. It is known as the rain shadow region or the leeward side, where air warms up as it descends. So the leeward side has dry conditions. It has very little or no rainfall at all. Now, if you look at this other depiction, you're gonna see that on the windward side, that's where you have heavy downpour. But on the leeward side, where you have descending air, you have literally little or no rainfall at all. So this is the rain shadow region or the leeward side. So this is very important for you to know. Now, let me take you into cyclonic or frontal rainfall. Now, this type of rainfall is purely associated with cyclonic activity. Now, when you just hear the word cyclone, what should come into your mind is wind or air masses. Wind or air masses, cyclone. So this is the type of rainfall which involves the convergence or meeting of different air masses with different temperatures and other physical properties. So air, which is cold, is very dense. You must know this principle. Cold air is denser than warm air. So as cold air is denser, it tends to remain, very close to the ground, whereas warm air is lighter and tends to rise over cold air. So this principle, you must know it. In ascent, pressure decreases and air expands and cools. Condensation takes place and lighter showers called cyclonic or frontal rain occur. This type of rainfall resulting from convergence of warm air and cold air is known as convergence rainfall. Now, warm and cold air converge, in a place known as the intertropical convergence zone or the frontal zone. This you must know. So warm air and cold air meet or converge in a place or an area known as the ITCZ. The ITCZ, the intertropical convergence zone. Now, like I earlier said, when cold air is moving from one end and meets up with warm air is forced to rise up and cold air remains closer to the ground. Now, if you look at this depiction here, you have warm air forced to rise over cold air. Why does warm air rise over cold air? Because warm air is lighter than cold air. So this line which you are seeing here is the convergence zone or the frontal zone. So this is a frontal line or the intertropical convergence zone. So this is a frontal line or the intertropical convergence zone where warm air meets up, cold air, and it is forced to rise up. When it rises up, it condenses after cooling to form clouds, which in the end drop in form of rainfall. So, as you're able to see, we have the tropical regions. Now, these tropical regions are the areas where you find the Tropic of Cancer above the equator and the Tropic of Capricorn below the equator at about 23.5, degrees. Now, these regions, that's where you find, the intertropical convergence zone, where warm air meets up with cold air to form convergence, cyclonic or frontal rainfall. Now, let me take you straight into the measurement of rainfall. How do you measure rainfall? Now, the instrument that we use to measure rainfall is known as a rain gauge. So the rain gauge is the instrument that we use to measure rainfall. Rainfall is measured in millimeters or inches. A rain gauge consists of the following parts: a metal or plastic container, a funnel, a graduate jar or measuring cylinder. Rain falling in the funnel trickles into, the jar or measuring cylinder. The measurements are taken every 24 hours at a weather station. Now, here is how a rain gauge looks like. So, this is a rain gauge. That's a rain gauge. Now, positioning of a rain gauge. So you don't put a rain gauge anyhow. You need to position it strategically so that you can collect the rain in that cylinder. Now, the first thing that you must do is the rain gauge must be sunk into the ground level. This is to prevent rain from splashing into the funnel from the ground. Apart from that, it must be sunk into the ground to also prevent excessive evaporation of rain from the jar. So that's very important. It must also be placed in an open space. This is to prevent runoff water from buildings and trees from entering the funnel. So the rain gauge is very, very important because that's what you use in order to collect the, the rain. Now, there's something that is very important which you must know. We have what we call weather maps. Now, on a weather map, all places having the same quantity of rainfall are joined by a line known as isoheads. Isoheads. Very important. Now, let me take you into examination questions. Now, when you look at, let me just take you back to the 2019 paper 2, Social Studies paper 2, 2019. This is section A, Geography. If you look at this diagram here, it is indicating a certain type of rainfall. Now, the first question says, Name the type of rainfall depicted in the diagram above. Now, whenever you see a mountain barrier, what should come into your mind is relief rainfall or orographic rainfall. So the answer here is orographic or relief rainfall. B, which specific area in Zambia usually has such type of rainfall? Now, you can just give any place in Zambia which you know where there are quite a number of hills or mountains. So the best specific area which you can give here is the Muchinga escarpment or the Zambezi escarpment. You can say Muchinga escarpment, Zambezi escarpment, the Mbala highlands, the Makutu mountains. All those are specific areas in Zambia which experience relief or orographic rainfall. We are getting now to C, which says describe two differences in rainfall activity of the opposite sides of the mountain. Remember, side A of the mountain is the windward side, which receives heavy rainfall, whereas side B of the mountain is the rain shadow or the leeward side, which receives very little or no rainfall at all. So that is one of the differences. So the difference between side A and B is that side A, which is the windward side, receives heavy rainfall, whereas side B receives very little or no rainfall. The other difference which we can give here is that side A receives moist, warm air, whereas side B receives very dry air. Very, very dry air. Let's get to question D, which says, in which season does the rain condition above occur? Now, this is during the rain season. Let's get to E, which says, give 2 reasons why farming practices would fail in the area marked B. Now, here you just need to use common sense. Since area B does not receive enough rainfall, it means there is drought and plants won't be able to grow. So one of the reasons farming activities would fail in area B is because there is very little or no rainfall, or there is drought. That is one of the reasons. Then the other reason you can give is that mountain slopes tend to have soil that is very thin, or soil which is not very good. Let's get to F, which says, state 2 other factors that cause rainfall to vary in Zambia. Now, one of the factors which cause rainfall to vary in Zambia, where some places tend to have high rainfall compared to other places, is the distance from the equator. So places which are closer to the equator receive higher rainfall compared to places which are far from the equator. The other reason is distance from the sea, or let's say distance from the ocean. Zambia is a landlocked country. It is surrounded by land masses. So since it is far from the ocean, you discover that the rainfall that it receives is not as much as it would when closer to the ocean. Let's get to G, which says identify an important rain-bearing wind to Zambia. Now, this is very important. The wind that brings rainfall in Zambia in northwest is the Congo air. The Congo air. So this is one of the most important rain-bearing winds to Zambia. On the southeastern part, we have what we call the southeast trade winds. So the southeast trade winds on the eastern part of Zambia, they're the ones that bring about rainfall to the eastern part of Zambia. The southeast trade winds. So those are examples of important rain-bearing winds to Zambia. Next question. So this is an extract from 2021 External Social Studies. So question 7 says, name the type of rainfall shown above. Now, whenever you see warm moist winds and cold dry wind meeting, all you have to think of is cyclonic rainfall, frontal rainfall, which is also known as convergence rainfall. So sometimes they'll say frontal rainfall, sometimes they'll say convergence rainfall, sometimes they'll say cyclonic rainfall. So the best possible answer here is convergence rainfall, where dry wind, cold dry wind is meeting warm moist wind. Question 8. What is the name of the line marked X? So this line marked X is the intertropical convergence zone. The intertropical convergence zone. So these are some of the examinations questions I wanted us to look at. Thank you so much for your time. I'll see you in our next meeting.